Hey guys, lesson 9, and it's Friday before Thanksgiving break, so this is going to be a great day. Let's get this done. This is a short assignment, so you should be able to finish in no time and then go back and finish anything that you were not able to complete before Thanksgiving break for your science class. All right, so this is your Thinking Deeper document, and it goes right along with your slides that are here as well. So let's look at our slides. So remember the navigation, slide A, we're talking about navigation, navigation, slide A. Okay. So the two questions are: how is light related to the original phenomenon of our ice drink warming up? And what other ideas do we have for things that could cause the ice water to warm up? So on this first question, think back to how the temperature changed with the light data from yesterday's assignment, from lesson eight's assignment. Um, how did light affect the water, the liquid inside the cup? That's what you'll put there. What other ideas did we have for things that could cause the ice water for warming up? So, what are some other ways besides light shining on the cup? What is something else that could affect the temperature inside of the cup? Pause this video, type your answers. Okay, and then this next section for slide B. So if you're looking at slide B, you can see the pictures a little bit more up close if you need that, but they are also here to the side. What are some different ways we can test whether heat from outside of the cup is going through the cup wall or whether cold from inside of the cup is coming out? So you could type a couple of ideas of how you might be able to test that in an experiment. The second question is how could changing the temperature of the air outside of the cup affect the temperature of the water inside of the cup? So if we had these two different situations, how would the air be affecting the water inside of the cup? Cold air, hot air. Pause the video, type your responses. Okay. Slide C. This is slide C. We got a little different situation here. If I put a cup of cold water inside of a bigger container that has hot water in it, so it's surrounded, cold water cup is surrounded by hot water. What would happen to the temperature of the iced drink if we put it in a tub of hot water? And then would anything happen to the temperature of the water? So the water that's surrounding the cup. Pause the video, type your responses. Okay, so on this part with the classes that we had in person, we didn't actually do this lab. So Mrs. Walker and Mrs. Lau's class didn't actually do this lab in person. So we can actually probably skip slide D. So maybe skip that one. But here is the water bath setup, slide D. So this would be the lab, like if we did it kind of like a mental experiment. So if I have water in this little cup, and then I have a different temperature of water in this bigger container, I put the cup of water into the bigger container that also has water in it. I have a different temperature. So submerge it, but make sure that the water doesn't go inside of the cup. It stays in its own little container. Put the lid on it, and then wait 5 minutes. And then I can take the temperature of the water inside of the cup and the temperature of the water in the container. Now, you can't really see if there's any differences in temperature because water's clear, whether it's hot or cold. So this is a drawing version. So this little insert here, this blue part in the middle, that represents the cold water in the smaller cup here, the smaller cup. This purple color here on each side represents the water that's in the larger container. So it's purple because red and blue make purple, and so red is hot, blue is cold, and if it's room temperature, it's a little mix of cold and hot. So that's why it's purple. So these are our test conditions. These are our test conditions. Now, if Mrs. We had 4 different situations here. We had them so we have hot water inside of room temperature, hot water inside of cold, cold in room temperature, cold water sitting in hot water. So if you have these different conditions, what would you expect to happen in each condition? Annotate the image. So what I would probably do here, if this is number 1, 2, 3, and 4, insert a text box right here. So you'll go to tool or, well, and I can't edit this because it's the original. So you would insert a text box and then just type 1. The hot water would do this, the room temperature water would do this. Like, what would you think would happen? And this is number 2, number 3, number 4. And then you can type what's going to happen over here. Okay. So pause to write your answer. And you know what? You can probably go ahead and do this based on, go ahead and look at slide D. Slide D. Look at slide D to fill this in as well. So pause to fill in slide D and slide E. Okay. Data set and analysis. Heat or cold across the cup wall. Slide F. And that is the slide here, slide F and G. So we have our data. It's all filled in over here. So the only thing that's over here, it's the same thing. Okay, so you've got all the same numbers over here. So you're going to be using the data from our little experiment that's from slide E. So using this data, so we have the inside of the temperature, the inside temperature is hot, the outside temperature cold is room temperature. This is hot inside, cold outside. So that's this experiment, hot inside, cold outside. Okay. So making sense of the data. Number 1, what patterns do you notice in the data? So I would go back and I would look at this and notice, is there anything that kind of stands out to you that makes you go, huh, that's unusual? And then see if it repeats it in the other data tables. That would be something you could put there. What patterns do you notice about the final temperature measurements? So remember, this little triangle here means change in temperature, but this is the final temperature. This is the data column they're talking about for number 2. So look at number 2 and read number 2. You're looking at this set of columns here. What do you notice about the final temperature measurements? What do you notice about them? And then what happens when you increase the temperature difference between the water inside the cup and the water outside of the cup? So here, these two have a big difference in temperature, inside and outside. These two, the temperature difference isn't as much. So what do you notice about the results for these two experiments compared to the temperature changes in these two experiments? So remember, this is temperature change. Okay, this column here. So the last column. And then using this data, what can we predict about how the temperature of the air around our cup could affect the iced drink inside? So using this experiment and this data, what would you predict about how the air temperature, if you had a cup on your desk, for example, how would that affect the ice cold drink on the inside of your cup?